Okay, so this is homework 3, part B. Via an energy balance, derive the relationship Bernoulli equation between inlet and outlet pressures, heights Z, average velocities, internal energy per mass, flow a steady state flow system with heat and non-flow work inputs per mass flowing through the system of Q over M and work over M, respectively. Emphasize in particular the origin and role of injection work in your derivation / explanation. So I've already drawn out the, the problem a little bit. Start off with mass, oh, mass times velocity plus gz plus v squared all over 2. So this is a rate of change. So we have these. Okay, then we do equals. So this equation is equal to, it will be equal to 0, but it is equal to the inflow of water minus the outflow. So we'll have M1 minus V plus G. And that'll be minus M2. At least we're gonna have dots over them. Basically just means it's gonna be like related to kilograms. So we have the same thing. V plus G plus E squared over 2. And then we also need the work that goes into this entire system. So that'll be W W N F plus Q. And then we also have the pressure. So that'll also be related to the mass of the in and out. So it'll be M1 times P1 over rho. And then we also need to subtract for the out. So that'll be P2 over rho. So next we need to get the potential or the pressure, the potential energy, and the kinetic energy all on the one side. So first we need the pressure. We have P2 minus P1 all over rho. Then we have plus G times Z2 minus Z1 plus V2 squared minus V1 squared all over 2. And we'll set that equal to, these are supposed to be U's. The software makes it hard to draw U, so I'll make that more clear here. We'll do U2 minus U1 plus, let me have work left plus And I forgot to add the dots here. And then what we can do is if we just do over meters, then we don't have to do the dot, and because that shows us related to meters here. So what we do is if we take this left half of the equation and set that equal to 0, that is the Bernoulli's equation. So we can see it here. This is the relationship between the Bernoulli's equation and the work and the input and output of this pipe system.